Hi, welcome back to Spring CS170. We're going to be looking at JavaScript function calls. We're going to pick up from where we left off before with arguments and parameters. So remember, argument is what you're going to be passing in when you make the function call, and parameters are on the function when you're receiving those arguments. Okay, so you remember we had like this coin flip function here. And then you see here, um, the coin flip doesn't have any inputs, right? You can see it's open paren, close paren, open paren, close paren, right? There's the function call. This is the actual function definition. Okay, now here we're going to add two numbers. The input is going to be two numbers, right? So these are your arguments, 3 and 5. And then here is your function, and here's your parameters, your input. These are declared as num1 and num2. Remember from the last lecture, we talked about these as the naming convention will be similar or pretty much the same as like the variables that you learned earlier. So you can see num1, num2. The usual criteria for illegal variables will apply here. Okay. So onto parameters. Basically, you look at it as what do you need to know to get the job done, right? So here's your input. You remember earlier we did the whole calculation for your total pay, right? So what do you need to know? Well, you need to know what your hours are and what is your rate of pay. So you get those two things in there, and you can see we declare the variable pay, and you set it equal to the hours worked times the rate of pay. Okay, so you did that all in one line here. And then you returned it, right? So you do a return of pay. Okay, so when I'm calling this function, I would say total pay, and I would put in these two numbers, hours worked and rate of pay, and then what I would get back is uh, the pay, the total pay. Okay, so what does that look like here? Uh, you know, we did this in the last lecture. We had the convert Celsius to Fahrenheit. So that's you calling it. Here's the value that you're going to pass in. And then on the function side, here's the parameter you're going to pull in. Okay, and then same thing on the BMI calculation here. Now on the function here, once we actually get into the function, you can see it looks very similar to what you were looking at when you were doing the flow charts. Okay, so you remember, I think of it, the sequence of steps is when you look at the program flow, you look at it as the flow chart to kind of give you like the high level logic, and then you translate into pseudocode, and then the next step would be to actually translate into real code. Okay, so those are the kind of the three ways I look at it. Let me see if I can zoom in on here a little bit. Actually, I'm over here. Here, zoom. Let's see what it looks like if I make it 200%. All right, so I think the thing I'll point out here is kind of what I talked about when I was talking about the flow chart in the first video for this week. So you remember, one input, two output, right? It's a binary thing, right? Yes, no, right? So is this base 16? And then you have the yes and the no out here, right? And it nests, right? So now once you say, well, yes, it is, then you say, based on the function, is it less than 10? If yes, then you're going to go down here. If no, then you're going to go over here, right? So this is less than 10, or is it equal to 10? Is it 11, right? Is it 15? So you can see how you can string together all of these conditionals into these different diamonds, right? But note, they're all two things, either yes or no coming out, I should say. But then once they're done, once you have the float, you see how all the lines come back together? Right, it comes back together here. Here's your output here. Here's some other outputs here. And they all end up going to this last oval here on the stop. So people that may be looking at their flowchart assignment might want to make note of that. That's kind of how you want it to go. You start off with the one oval, and then everything has to come back together here. And even though you have all of these different paths that you're taking, that's okay. They can all come together like this. Um, sometimes you put like a little dot here to bring them together, or like a little circle, or you just kind of connect it like this. It's fine. Either way is acceptable. Okay. Let me zoom back out here. Just make it 150. 150. There. Okay. Now, I just zoomed in here just to kind of talk about the flowchart, but you can see here's like the main logic over here. And don't worry, I'm going to save this PowerPoint as a PDF into the resources after we get through this. So you'll see that you can refer to it. Okay, so you're here, this is your main flow, then you make a call, and then it's just like this, almost like this little mini program going on here. This is your function, right? And then the function will return, and it comes back here, and then your main processing will continue here. Okay, so this kind of gives you an idea of like your main flow, and then the function call, and then it comes back to the main flow. Okay. Okay, now this one is like an example of a function that doesn't return a value. So a lot of the stuff that you've been looking at is you make a call to the function and return something, right? So like these things, right? If you convert your Celsius to Fahrenheit, you're going to get something back to say what's the Fahrenheit temperature. In this case, you're not going to return anything, and all you're going to do is do an alert. Okay, so here's the function, the BMI. Here's the variable, and then you do the BMI equals to this. Okay, this is just a different way of doing it, right? You could have done the var BMI equals to, and then you do all of this in one line. They broke it up into two lines, do the var BMI, and then do the BMI equals to this, right? Instead of doing the return like you've seen in previous examples, you would do an alert. Right, so alert just pops up a box and it says your BMI is blah, blah, blah. Okay, so this is a function that doesn't return a value. So functions don't always have to return a value. Okay, so that's just all it's showing. Now you're doing something where the function does return a value. Okay, so here and this one, they really squished it up into one line here, which is valid. Okay, sometimes it's good to do that. Sometimes maybe not, right? So it depends on the situation. But in this case, they calculate everything in one line, right? So they took in these two parameters, did these calculations, and then did the return all in one shot in one line here. Okay, so this is valid thing to do, and this is returning a value. Okay. All right. So here, they're just kind of clarifying the definition versus a call, right? So declaration is like you defining the function to be called, okay? The Fahrenheit to Celsius, let's say, right? So you're saying, okay, well, here's the input that I'm going to take in, here's the calculation I'm going to do, and that's what I'm going to do to return it, okay? So the declaration is only once, of course. You don't want to declare that multiple times. That's going to confuse the computer. And the function can be called many times, right? Which goes back to my point before. You can call it anywhere in the program. That's fine. So these 2 points are notable to distinguish between like the definition versus the call. Okay, and the functions can be put anywhere in the JavaScript. Okay, and so for example, I could have put it like in the script section in the header, or I could put it in the body. And then they'll just be there. They're ready to be accessed wherever in the code, okay? And they'll call it, and then you'll be able to run it, okay? The JavaScript also provides some built-in functions. In the example, we showed you the math.random, right? And you can see that here at the bottom right, math.random. Excuse me. But you see all these other ones here. So these are, I think they're kind of self-explanatory if you look at them, right? So you make it an integer, you make it a float. A floor is like if I give you a number, like let's say 4.5 or something like that, If you want to do a floor on it, you're basically just truncating it and just taking the 4, right? Rounding it is your usual rounding rules. Well, I don't know if I should say usual rounding rules, right? But there is rounding rules that's associated with that. You use this for rounding to however many decimal places you want to round it to. Math.random, you know, you can easily see that function in that example that I showed to you on js.do, which is over here. Okay, random number. Okay, and note the comment here. I showed it to you last time. Generates a random number between 0 and 1. So you say, well, okay, what good does a random number between 0 and 1 do me? All you have to do, let's say you want to do like, a number to 100. Like, what's a random number between 0 and 100? Well, all you have to do is take that and multiply it by 100. Okay, so the fact that it shows you like a random number between 0 and 1, once you take a multiplier to it, then you could actually be a random number between 0 and 100, let's say. So that's all you have to do when you have a random number that you want to have a certain range that's not between 0 and 1, which is what the function will give you. Okay. Alert, you've kind of seen examples of that, right? Alert, and then pops up the box. Okay. Prompt is for input. You can do a date, you can convert something to like a string, convert it to a number, to fixed, right? Okay, so we have local versus global, right? I think I mentioned in the last lecture what is a global variable. So a global variable is something that I can declare. You can use anywhere in the code, whether it's in the function or in the main body of the code or wherever, you'll be able to access that. Okay, and a local variable would be within the function. So within the function, I declare that variable. It's only valid while it's inside that function. Anytime outside that function, it's not going to be accessible or visible to anyone else, like in the main code, let's say. Now, and we're going to probably test you. Well, not say probably. We will test you on this. This is called variable scoping. So within like one particular part of the code, the variable, what does that value mean, right? And it gets tricky when you start to use the same name variables, both at the global level and at the local level. Then people kind of get confused. So you have to be very careful with this, okay? So you have to follow along, and then you can kind of trace what it is, okay? So in this case, you have this is outside the function, right? So you have the function here is declared, calc beta ABC, and then you have var x equals to 1, y equals to 2, z equals to 3, and then answer equals to 0. Okay, now here's the tricky bit, right? Now look inside this function calc beta, you can see the var x and y. This is not the same x and y as you declared up here in your global variable. Right, this x and y is x equals to 1, y equals to 2. This is a new x and y. So this is why I'm telling you it's not a good idea to reuse the same name variables because it gets messed up and confusing to the human, right? The computer knows what's going on. So now here, this is a copy. No, I shouldn't say a copy. It's a local copy of a location variable. Okay, so this is x and y here. Don't mix it up with this x and y up here at the top. That's the global variable. Okay, so now you say, well, okay, x equals to 2 times a, y equals to b plus 3, whatever, right, times c, and z equals to 7. And then you return x and y. Okay, so you can see up here, again, there's another thing you should be wary of, right? So you see calc beta, these are your arguments that you're passing in, x, y, and z. Okay, now your parameters is a, b, and c. So all that means is whatever was in x, that becomes a. Whatever is in y, that becomes b. Whatever is in z becomes c, right? So in this case, this a, right, 2 times a is what? Well, this a is 1, right? So 2 times 1, x equals to 2, right? X equals to 2 within the function, okay? And then y equals to b plus 3 times c. So what, b is 2, z is 3. So you plug that into here. So 3 times 3 is 9, plus 2 is 11, so y is 11, okay? And then z is 7, right? And then z kind of gets thrown away over here because then you have a return x plus y, all right? So here, x plus y is 2 plus 11 is 13, okay? So that's what's going to come out here. This ANS equals to 13, okay? So let me just remember if I double check this, right? So this is C is 3, so 3 times 3 is 9, plus 2, yeah, so 11. So 11 plus 2 is 13, okay? So what's the final value here? So answer is one thing, right, which is the 13. So x, well, x, y, or z, this is where you need to pay attention and be careful here, right? The final value means like we've exited out of this function. We're no longer in there. So whatever happened in here is gone, right? After this is returned up here into your answer, that becomes 13. So the x will actually be this value here, 1, right? And then this y will equals to 2, and the z will equals to 3. Okay, so that's the point. What this is trying to demonstrate is the difference between your local and global. When you see this, which you'll see some variation of this on the exam, I'm telling you that, right? So you're gonna definitely have this on the exam. Pay attention here, okay? So once you exit out of this function, all this stuff is gone, right? And you come back to here, minus the result. The result is this answer that got returned here. Okay, so I hope that's kind of clear to everyone. So you'll be asked to do some sort of variable tracing for the exam, so keep that in mind. And when you do your assignment, my suggestion is don't overlap variables like this, right? It's just going to confuse the heck out of you. Okay? All right, so I think I'm at the 17-minute mark here, so I'm going to take a pause here and I'll cut a new video for these guys down here. All right, thank you.